Now we come to some rules or properties of the inverse matrix. This is really part of the definition, but we can make it as a rule or property. A matrix times its inverse is the identity matrix. If we take the inverse matrix and then take the inverse of that, then we're back to the original matrix. Before I comment on this, let me just say that for a matrix A, we can raise to a power. If I write something like a to the power of 3, I just mean the product a times a times a. We don't have a meaning for a to a negative number, but we can, what we can define it as is either the inverse of a to the power of n, or a to the power of n and then the inverse of that. Turns out it doesn't matter if you first take the inverse and then raise to a power, or raise to a power and take an inverse. In both cases it's the same thing, and we call it a to the minus n. This rule kind of reminds me of the transpose, because there also we had an inversion. Now, if you take the inverse of AB, it's not the inverse of A inverse of B. You have to reverse the order. It's the inverse of B times the inverse of A. Very important. Take note. Do not get confused. If I multiply a matrix by a scalar k, well, should not be 0, then, and I'm going to take the inverse, it's the same as taking the inverse and then dividing by k, or 1 over k times. Let's see, a few more rules. Well, not exactly rules relating to the inverse, but while we're at it, a couple more exponent rules. Just like with numbers,